Sure, my name is Dr. Mark DeCoster. That's M-A-R-K-D-E-C-O-S-T-E-R. And I'm a professor here in biomedical engineering and the Institute for Micromanufacturing at Louisiana Tech University.
Okay, and if you would just look at me. Get my questions pulled up.
And this is why we don't need business cards anymore, because we have digital.
That's right.
Yeah.
That's right. Okay, so explain what the new program is all about.
Yeah, so this new program that we're now involved in is called DARPA SMS. And SMS stands for Simulating Microbial Systems. And so we're part of a 3-team project led by Radiance Technologies, a business which has a presence here at Louisiana Tech. And we're partnering with LSU Health Sciences Center in Shreveport. And then Louisiana Tech is also involved, and I'm leading our group. Our group at Louisiana Tech is going to take experimental data from microbes under certain conditions, defined experimental conditions. We're going to take digital images, microscopy, metabolism, different parameters of how these microbes behave. And then we're following, you can think of this as a design, build, teach, learn model iteration. So we design the experiments, then we build the experiments like in a plate or a petri dish, and then we teach the system through information, and then we learn from it. And of course now this means multiple faculty. I'm a biochemist and a biologist, and we also have on the team chemical engineers, people from chemistry and physics and computer science. So the learning and the testing will be both experimental as well as informing simulators and modelers to understand how the microbes react in reality, as well as predicting what they might do in the future. And so it's an iteration loop of design, build, teach, and learn.
How does Radiance Technologies play into this?
Right, so we're very excited to be teaming with Radiance Technologies because they have a long-standing trusted partnership with government big projects. So I consider this great opportunity here to partner with a strong project-leading corporation like Radiance, as well as computational skills. So they have a great appreciation for big data, how to manage it, how to secure it, how to move it, and then inform and teach those involved what that data might mean.
How will the $5.85 million be spent?
Right, so that is going to be distributed basically in 3 partnerships, led by Radiance, and then LSU Health Sciences in Shreveport, and then Louisiana Tech University. So this will be spent to benefit, for example, the PI. I'm the investigator in charge at Louisiana Tech. I have 3 co-investigators, so these are professors that have their own teams, and then this will distribute down to benefit students at Louisiana Tech, both graduate students and undergraduate students. For example, at LSU Health Sciences Center, this will also benefit faculty, core labs, where they'll be doing a lot of big data generation. And then at Radiance, we know that one benefit of having them on our campus here at Louisiana Tech is they will actually be recruiting interns and hiring students who may become employees of Radiance in the future.
How long do you think this project will go on?
This project will go on at least for 18 months. That's the formal budgeted period. But we're already excited about expanding this with what we achieve here as milestones for future sustainable projects and generating collaborations. For example, 3 other universities or groups were awarded under this competition. Our group was one of only 4 in the whole United States. This includes Stanford, people in California, and so DARPA is encouraging us to collaborate and communicate with them and possibly build out more sustainable projects in the future.
Will this project have implications for biological warfare?
Possibly. So DARPA has defense interests, but we're not looking at that specifically. We're looking more at the general biological behavior of microbes, and in fact we're choosing a microbe, E. coli, that is normally in our gut. So we want to understand how a normal, non-pathogenic microbe exists normally, and then put it under certain testing conditions to help predict how it might respond, for example, to antibiotics. So we want to understand how the E. coli can normally behave, but also respond to antibiotics or certain threats that might include disease. And yes, there could be some defense measures that we want to understand.
Will this have any type of impact, like with the COVID crisis that came out of the Wuhan labs? Mm-hmm. Are you looking toward to a possible future outbreak that this, I guess, defensive mechanism, studying the E. coli, another possible strain like COVID might come along? And then does it have implications for being able to fight that? Is that what the national security implications are all about?
I think that's a very good question. So COVID involved viruses. These involve bacteria. As I said, the E. coli, the bacteria that we're studying, are normal in our gut. But I think in general, we as a nation and as scientists want to understand potential threats coming up. And so being able to understand how, in this case, a microbe, normally in us, E. coli, might respond normally and under antibiotic conditions, understanding that and helping to predict what it might do in the future, I think could help us understand potential threats in the future, which, as we understand from COVID, had worldwide implications.
How will it impact healthcare, the healthcare sector?
Right, so the healthcare system, that could be very relevant because we have something called the microbiome. So our E. coli is in our gut. It helps us with digestion, but also, as we know, we can get bacterial infections or disease that can affect health in many ways in normal people, as well as those with other disease states. So I think in general, considering we had a need for a very strong partner in LSU Health Sciences Center, of course, Heretta Medical Center, Louisiana Tech, we have computational and basic science research. Putting it all together with a company like Radiance, I think, can have implications for healthcare projects in the future as well.
Are you getting people hired, or are you just kind of going from your student pool to get them, I guess, paid researchers? And how exactly will that work? Are you attracting anybody from outside to that this, to pay them to do some of the work? How is that going to work?
Right, that's a good question. We're mostly, since we want to hit the ground running, we're hiring from within. Our student body is a great pool for recruiting and hiring, but also connections, collaborations we've had through LSU and Shreveport, or here at Radiance or Tech. We are trying to bring some people back with this new opportunity, and we're looking at a few opportunities to bring new people in. It's an intense, well-funded, but short-term project, and so initially we're hitting the ground running with our student pool.
So what would be the impact for the everyday person that you're getting this, you're learning about this, and how will that impact them? Just, I guess, the average person who might, I guess, would come down with or get infected with an E. coli infection? Is that what you're kind of looking for?
I would say not to worry too much about E. coli infections other than what we've always dealt with, but maybe a better ability to incorporate computers, big data, to understand how E. coli bacteria might respond to antibiotics, both normally. The lay public may have heard of resistance, antibiotic resistance. This is a general healthcare concern that this project may help us model resistance to certain antibiotics. Because we never know exactly what those challenges will be in the future. So it could, down the line, affect people, better availability of drugs in the pharmacy, and general healthcare for a normal bacterium, but then can go bad in certain healthcare situations.
And you'll be using artificial intelligence to run stimulations, is that right?
Absolutely. That will be something that is a big tool out there, and yep. Yeah, definitely. That definitely is a big tool that's out there. I think we've all heard a lot about artificial intelligence. In my opinion, we should not just blindly accept what AI may suggest to us, but part of this design, build, teach, and learn is to actually teach AI what the appropriate answers might be, and then it will learn and suggest to us answers for our research. So as a neuroscientist, as an experimentalist, I see great power in AI and the computing technology, but we need to make sure that we're equal partners, that we don't always trust what AI can do blindly, but it can definitely be a strong tool here, yes.
Are you excited to get started?
Very excited to get started, and it's great timing because the fall quarter has just started here at Louisiana Tech. Students are always eager, and when they hear about research opportunities, this may help build their future.
How big is your department?
Our department of biomedical engineering is about 11 faculty, but we're also connected to the Institute for Micromanufacturing, which is about another 20 faculty of different programs here at Louisiana Tech. And so this is definitely an interdisciplinary project where we have 4 different programs involved, and then those programs have their own students, and but we're all working collaboratively together.
About how many students would you say are in your field of study?
Go ahead. Yeah. Our field of study for this project is probably about 40, 50 students, and that ranges from undergraduate, master's students, and PhD students, as well as some postdoctoral fellows. These are people who have already earned their PhD and will be working more formally without having to take classes to concentrate on the project.
Anything else you want to add?
No, I'm just really glad that we could announce this venture, and it's really demonstrating again a lot of the activity on the I-20 corridor and how collaboration can lead to great results.
Okay. Stay right there for just a second.